This morning, you probably weren't thinking about war. You were drinking your coffee, maybe checking your phone. But right this second, a battle is raging inside your body that hasn't stopped for a single day in the last 3 million years. This isn't a metaphor. It's not just a poetic intro. It's the longest, bloodiest, and most untold war in the history of our species. And you've been a soldier in it from birth, whether you like it or not. Historians love to talk about wars between kingdoms, empires, and ideologies. 100 years here, 1,000 years there. Textbooks measure conflicts in decades, sometimes centuries, and that feels like an impressive scale. But there is a conflict older than language, older than fire, older than the word human itself. The enemy is invisible to the naked eye. It has no flag, no capital, no diplomats to negotiate with. Its name is disease. Sometimes it goes by another name, parasite. And this war has nearly wiped our species off the face of the planet not once, 45, but dozens of times over hundreds of thousands of years, leaving behind after each wave only a handful of survivors whose genes you carry inside you right now. Think about that scale for a second. Every known civilization, every great battle you read about in school happened in the last 5,000 or 6,000 years. That's less than 1/10,000th of the war we're talking about. The vast majority of this conflict was fought with no witnesses, no chroniclers, not a single word to describe what was happening. And that's exactly why we know almost nothing about it, until we start looking for clues where we least expect them. In fossilized bones. Let's start with something that will shatter your perception of your own ancestors. Did you think ancient humans were tougher, purer, closer to nature? That cancer, tumors, and infections are the price we pay for civilization, fast food, and the smog of big cities? In 2016, paleoanthropologists examined a fossilized foot bone nearly 2 million years old, found in a cave in modern-day South Africa. It belonged to a creature of the genus Homo, one of the earliest ancestors in our lineage. 45 in the bone showed clear signs of osteosarcoma, an aggressive, malignant cancer. Think about that. A creature who never saw a cigarette, never ate refined sugar, and never sat in an office was dying of cancer exactly like people do today. Evan Hoffman and his colleagues who published this research essentially rewrote the history of the disease. Cancer isn't a byproduct of a comfortable life. It's an ancient tax on multicellularity itself. The price you pay for having a body made of trillions of cells that agreed to cooperate. Sometimes one of them breaks the deal. It has always been this way. But if cancer has always been around, why do we call it a modern epidemic? The answer is deceptively simple. People simply didn't live long enough to get it. That ancestor from the South African cave was far more likely to die from an infected scratch, a toothache that turned into sepsis, a predator's bite, or just plain starvation during a bad season. Short life expectancies kept cancer in the shadows. Tumors need time to grow, and almost no one had any time to spare. Long before the microscope, long before germ theory, your ancestors were already waging chemical warfare against an invisible enemy. They lost more often than they won. But they fought back consciously. They didn't just endure. If ash was the shield, plants became the sword. The ancient Chinese pharmacological treatise Shenong Bencao Jing, with roots stretching back thousands of years, mentions cannabis as a remedy for malaria, like fevers, as well as joint pain and spasms. The text doesn't provide modern diagnoses. It offers observations accumulated by hundreds of healers over centuries. This plant reduces fever. This plant relieves pain. This plant kills whoever drinks it, so don't do that again. On the other side of the world, in ancient Egypt, the Ebers Papyrus, one of the oldest surviving medical texts, dating back roughly 3,500 years, contains dozens of specific herbal prescriptions for infections, inflammation, and parasitic diseases. This includes what modern researchers interpret as early forms of schistosomiasis, a disease carried by parasitic worms in contaminated water. These texts weren't the idle superstitions of random shamans written down out of boredom. 45 seconds / greater than DN. A mutation rate analysis revealed the exact moment these two species diverged, about 170,000 years ago, long before humans migrated out of Africa. This number isn't just a random statistic in a biology textbook. It's a fossilized date in the biological clock that tells us something highly specific. That is precisely when humans started wearing clothes all the time, day in and day out, rather than just occasionally on particularly cold nights. Think about what that actually means. We didn't just invent clothing for warmth or modesty, as we're usually taught in school. We created an entirely new ecological niche, a narrow, dark, warm space between fabric and skin. And nature, as always, instantly spotted the vacancy and filled it with a new creature. The parasite evolved and adapted faster than we could enjoy our invention for even a couple of millennia. Every time humanity found a new way to defend against the cold, starvation, or predators, a disease or a parasite found a way to bypass that defense and use it against us. This isn't a one-off battle, won and forgotten. 45 seconds / greater than. It's an endless arms race happening right now, this very second. Just on a timescale you physically cannot perceive within your short lifespan. But what if our defense wasn't just in the fabric we wore, but in where we slept? In South Africa's border cave, archaeologists found what looks like a bed dating back over 200,000 years. The oldest known human bed. It was made of layers of dry grass, but beneath those layers, researchers found something else. Concentrated campfire ash. Lynn Wadley, who studied the find, suggested the ash wasn't just random debris. It was a barrier. Modern entomologists know that alkaline ash repels ticks, fleas, and other crawling disease vectors. Ancient humans probably didn't know the word pathogen, but they knew one thing for sure. Where there is ash, there are fewer bites, less itching, and less sickness. So they deliberately started layering their beds with ash over and over again. This was science without a name. Observation, hypothesis, experiment, repetition, all the steps of the scientific method. Executed by someone who had never heard the word method. Long before the microscope, long before germ theory. Long before the microscope, long before germ theory. Your ancestors were already waging chemical warfare against an invisible enemy. They lost more often than they won. But they fought back consciously. They didn't just endure. If ash was the shield, plants became the sword. The ancient Chinese pharmacological treatise Shenong Bencao Jing, with roots stretching back thousands of years, mentions cannabis as a remedy for malaria, like fevers, as well as joint pain and spasms. The text doesn't provide modern diagnoses. It offers observations accumulated by hundreds of healers over centuries. This plant reduces fever. This plant relieves pain. This plant kills whoever drinks it, so don't do that again. On the other side of the world, in ancient Egypt, the Ebers Papyrus, one of the oldest surviving medical texts, dating back roughly 3,500 years, contains dozens of specific herbal prescriptions for infections, inflammation, and parasitic diseases. This includes what modern researchers interpret as early forms of schistosomiasis, a disease carried by parasitic worms in contaminated water. These texts weren't the idle superstitions of random shamans written down out of boredom. They lost and they won the shield and the sword. The ancient Chinese pharmacological treatise Shenong Bencao Jing, with roots stretching back thousands of years, mentions cannabis as a remedy for malaria, like fevers, as well as joint pain and spasms. The ancient Chinese pharmacological treatise Shenong Bencao Jing, with roots stretching back thousands of years, mentions cannabis as a remedy for malaria, like fevers, as well as joint pain and spasms. The text doesn't provide modern diagnoses. It offers observations accumulated by hundreds of healers and parasitic diseases. This includes what modern researchers interpret as early forms of schistosomiasis, a disease carried by parasitic worms in contaminated water. These texts weren't the ideas of random shamans written down out of boredom. 45 seconds / greater than. But what if there's a creature that has almost won this war against cancer, the very disease we started this story with? Biologists long puzzled over a mystery known as Peto's paradox, named after Richard Peto, the epidemiologist who first articulated the anomaly in the 1970s. But what if there's a creature that has almost won this war against cancer, the very disease we started this story with? Biologists long puzzled over a mystery known as Peto's paradox, named after Richard Peto, the epidemiologist who first articulated the anomaly in the 1970s. The logic is straightforward. The more cells an organism has and the longer it lives, the higher its chances of getting cancer should be. More cells mean more opportunities for division errors, and more time means a greater chance to accumulate those errors. An elephant is hundreds of times larger than a human and lives for nearly as many decades. By all the laws of statistics, it should die from cancer far more often than you do. But it doesn't. The cancer mortality rate in elephants is under 5%, whereas in humans, that figure sits around 20%. Research published in 2014 by Joshua Schweitzer and his colleagues uncovered the reason behind this anomaly. Elephants have up to 20 copies of the TP53 gene, a gene humans only have 1 or 2 copies of, which is responsible for destroying damaged cells before they turn into tumors. 45 seconds / greater than if it evolves faster than we can invent defenses. Do we have any real advantage at all? Or are we just the lucky survivors of nature's random lottery? The answer lies not in biology, but in something biology alone could never create: a memory that lives outside a single body. The use of ash in the border cave bed was passed down orally from parent to child until someone thought to record that knowledge on clay, papyrus, or paper. The recipe for malaria in the Chinese treatise didn't die with the person who discovered it. It survived dozens of generations and eventually led to the isolation of artemisinin, a drug that is saving millions of lives from malaria right now, in this century. No other animal on the planet is capable of this. An elephant can inherit guardian genes, but it can't leave a recipe for its grandson. A human can. That is why this war, despite all its brutality, doesn't look like a defeat. Every time you wash your hands before eating, you're wielding a weapon your ancestors forged at the cost of countless deaths. And if it evolves faster than we can invent defenses, do we have any real advantage at all? Or are we just the lucky survivors of nature's random lottery? The answer lies not in biology, but in something biology alone could never create: a memory that lives outside a single body. The use of ash in the border cave bed was passed down orally from parent to child until someone thought to record that knowledge on clay, papyrus, or paper. The recipe for malaria in the Chinese treatise didn't die with the person who discovered it. It survived dozens of generations and eventually led to the isolation of artemisinin, a drug that is saving millions of lives from malaria right now, in this century. No other animal on the planet is capable of this. An elephant can inherit guardian genes, but it can't leave a recipe for its grandson. A human can. That is why this war, despite all its brutality, doesn't look like a defeat. Every time you wash your hands before eating, you're wielding a weapon your ancestors forged at the cost of countless deaths and thousands of years of observation. Every time you pop a pill, you're holding the result of a millennia-long truce negotiated with plants and mold. Every time you bundle up in clothes on a cold day, you are unwittingly carrying on the exact strategy that split lice into two species 170,000 years ago. Think about the hominid from that South African cave whose footbone bore the marks of cancer for almost 2 million years. He didn't know what was happening to him. He had no word for his disease, no way to stop it, no way to pass a warning on to his children. He simply died, just like countless creatures before him. But the war didn't end with his death. It continued through everyone who lived long enough to leave offspring. Through everyone who noticed the ash in the fire pit and didn't dismiss the thought. Through every herbalist who wrote down a recipe that worked even once. This morning, you probably weren't thinking about war. But now that you've read this far, think again about the coffee you drank earlier. Think about the fabric of your shirt. Think about the pill in your medicine cabinet that you've never even opened, but always could. These are all trophies from the longest war in the history of your species. The war isn't won. It may never be fully won. But for the first time in 3 million years, we have something none of our ancestors had. We can look the enemy in the face, and more importantly, we can pass that knowledge on.